Hello, Tom from Every Step Physics, everystepcalculus.com. This is a physics problem that was on the internet. I thought I'd answer it, show you how my programs work. I'm the only one that cares whether you pass your classes or not, so keep that in mind. Maybe there's somebody else, a few other people, but I'm the one that actually allows it to happen if you buy my programs. You'll notice here you're on a Ferris wheel that rotates 1 revolution every 8 seconds. The Ferris wheel operator brings the wheel to a stop and puts a brake on that produces a constant deceleration of minus 0.1 radians per second squared. If your seat is on the Ferris wheel and 4 meters from the center, what is your speed when the wheel is turning at the rate of 1 revolution every 8 seconds? Notice how dumb a lot of these problems are. The radius is 4 meters from the center, so that's an awfully small Ferris wheel. And certainly no Ferris wheel that I've ever been on is that with that radius like that, etc. But they just throw these problems out here for tests and to see if you can pass it or figure out how to do it. When I do these problems, I'm going to show you how much you have to memorize nonsensically. I mean, you have to memorize it and put it in your memory when there's so much more you could be putting in your memory from other classes or whatever. And you have to take a long time to study this to get this in your memory to do this problem, okay? So, but let's do it. Physics to get to my main menu. And we're going to go down here to angular acceleration. That's what they give you here, angular acceleration, deceleration. Anytime you see s squared, you're in angular acceleration. You're in some sort of acceleration. Remember, in linear, it's meters per second squared. Here's radians per second squared. So then you know it's acceleration. And because it's a round wheel, you're talking about angular acceleration, okay? So that's what you choose in my menu. And I ask you this, any number of, most of the time you're trying to figure out what the angular acceleration is in problems, so they give you other variables that you have to try to figure out what the angular acceleration is. But then, of course, they throw in something like this where they give you the acceleration, and they use algebra to figure out all the other, what you can derive from these variables and formulas. So I had to put this in my programs, which is cool. Once I program it, it's over. So I ask you whether this is in your problem, and if it is, then you say yes. You press the number before it or scroll to it. I say it's number 1 is yes. Enter angular acceleration or constant acceleration or any acceleration given with rads s squared displayed. Sometimes they'll change the words, like for instance this was constant deceleration. But the thing that makes you know it's this acceleration is this second squared, okay? So we're going to add the variables. You have to press alpha first in my programs, and the angular acceleration given by this character Greek letter here, the A, cursive A, is minus 0.1. I show you what you've entered. You can change it if you want. I say it's okay. And we're given revolutions, time, and radius. We're going to choose number 2. We're going to enter the revolutions. Alpha 1 revolution. And it's revolutions per second because it's 1 revolution for 8 seconds. Choose number 2. Convert to radians. We're not going to be converted yet, but it all has to be converted to radians. But I'll show you why in a second. So we say no there. We're going to enter the time, alpha 8 seconds. Enter the radius, alpha 4. Here's 4 meters for the radius. Number 3. And I show you again if everything's correct. It certainly looks good to me, so we're going to say yes, okay, and do the calculations. If you have 1 revolution in 8 seconds, that means there's 0.125 revolutions per second, okay? And that turns into angular velocity, which is indicated by this omega here, and then the I is initial. In a lot of physics, they would have WO here, you know, and then the nerds and the professors like to use not, meaning the beginning of the calculations. But then they give you the initial, so I always use WI, and many other professors do too, I. So this is omega I, initial revolutions per second, because there is a final revolutions per second too in all formulas. Initial velocity, final velocity, etc. And so then we change it to radians, 0.7854 radians per second. And then they ask you to how long does it take, or no, what is your speed when the wheel is turning? Speed is is linear velocity also, and turns out to be 3.1416 meters per second. T is stopping time. How long does it take for the Ferris wheel to come to a stop? Here's the formulas. Here's omega final minus angular velocity final minus the initial. And of course when you're stopped it's 0, so then we're subtracting the initial velocity or angular velocity from here, dividing it by the angular acceleration. Turns out to be 7.8454 seconds. Here's the formula for figuring out the angle of revolutions till it stops. Then we put in the calculations. Turns out to be 3.0843 radians. And then how far have you traveled? Well, we change that to revolutions, 0.49087 revolutions. Sorry, this isn't the previous answer here. For the distance that you've traveled is 12.337 meters. You're going around the Ferris, so it's a circumference. That's radius times the angle, and turns out to be 12.337 meters. So you got an A on this test and these several problems. Remember that physics tests are used for partial credit in the class curve, so you just need to get a few correct, and then you pass the test and you move on with your life. Never touch it again. So anything you put down in your paper, of course, is a couple of points, 2 or 3 points, whatever, and you keep adding it up for partial credit, and that's what you compare yourself to the rest of the class, okay? So anyways, go to my site, buy my programs, and enjoy passing calculus or physics. I've been in this business for 27 years now, and it's just amazing how this calculator can do these, and the program from MIT that I use for these calculations in a calculator. And notice this is the greatest notes you possibly could have. You know, if you could do notes off your professor's board like I did, and not only do you notes in your notebook, but you actually can change the variables in your calculator and do the problems for years to come, forever. So you don't need your calculus book or physics books anymore, you just need this calculator. So anyways, good luck in your classes, have a good one, okay? I'm all for you passing your classes.